This is Chapter 14, Book 2, of A Journey in Other Worlds. This LibriVox recording is in the public domain. Recording by Tom Weiss. A Journey in Other Worlds, Book 2, Chapter 14. The Scene Shifts. Having returned the rugs to the Callisto, they applied the maximum power of the batteries to rising, closed all openings when the barometer registered 30, and moved off into space. When several thousand miles above the pole, they diverted part of the power to attracting the nearest moon that was in the plane of Jupiter's equator, and by the time their upward motion had ceased, were moving well in its direction. Their rapid motion aided the work of resisting gravity, since their car had in fact become a small moon, revolving, like those of Uranus or that of Neptune, in an orbit varying greatly from the plane of the ecliptic. As they flew south at a height ranging from 2,000 to 3,000 miles, the planet revolved before them, and they had a chance of obtaining a thorough view. There were but a few scattered islands on the side of the northern hemisphere opposite to that over which they had reached the pole, and in the varying colors of the water, which they attributed to temperature or to some substance in solution, they recognized what they had always heard described on earth as the bands of Jupiter, encircling the planet with great belts, the color varying with the latitude. At about latitude 45, these bands were purple, farther south light olive green, and at the equator a brown orange. Shortly after they swung across the equator, the ocean again became purple, and at the same time a well-defined and very brilliant white spot came into view. Its brightness showed slight variations in intensity, though its general shape remained unchanged. It had another peculiarity, in that it possessed a fairly rapid motion of its own as it moved eastward across the surface of the ocean. It exhibited all the phenomena of the storm they had watched in crossing Secretary Deepwater's Bay, but covered a larger area and was far more violent. Their glasses showed them vast sheets of spray, driven along at tremendous speed, while the surface was milky white. "This," said Bearwarden, picking up a book, "solves to my mind the mystery of the white spot described by the English writer Chambers in 1889 as follows: During the last few years a brilliant white spot has been visible on the equatorial border of the great southern belt. A curious fact in connection with this spot is that it moves with a velocity of some 260 miles per hour greater than the red spot." Denning obtained 169 observations of this bright marking during the years 1880 to 1883, and determined the period as 9 hours, 50 minutes, 8 7/10 seconds, 5½ minutes less than that of the red spot. Although the latter is now somewhat faint, the white spot gives promise of remaining visible for many years. During the year 1886, a large number of observations of Jupiter were made at the Dearborn University, in Chicago, by Professor G. W. Hoe, using the 18½ inch refractor of the observatory. Inasmuch as these observations are not only of high intrinsic interest, but are in conflict, to some extent, with previous records, a somewhat full abstract of them will be useful. The object of general interest was the great red spot. The outline, shape, and size of this remarkable object has remained without material change from the year 1879, when it was first observed here, until the present time. According to our observations, during the whole of this period it has shown a sharp and well-defined outline, and at no time has it coalesced or been joined to any belt in its proximity, as have been alleged by some observers. During the year 1885, the middle of the spot was very much paler in color than the margins, causing it to appear as an elliptical ring. The ring form has continued up to the present time. While the outline of the spot has remained very constant, the color has changed materially from year to year. During the past 3 years, 1884 to 1886, it has at times been very faint, so as barely to be visible. The persistence of this object for so many years leads me to infer that the formerly accepted theory, that the phenomenon seen on the surface of the planets are atmospheric, is no longer tenable. The statement so often made in textbooks, that in the course of a few days or months the whole aspect of the planet may be changed, is obviously erroneous. The oval white spots on the southern hemisphere of the planet, 9 degrees south of the equator, have been systematically observed at every opposition during the past 8 years. They are generally found in groups of 3 or more, but are rather difficult to observe. The rotation period deduced from them is nearly the same as from the great red spot. These spots usually have a slow drift in longitude of about 5 seconds daily in the direction of the planet's rotation when referred to the great red spot, corresponding to a rotation period of 20 seconds less than the latter. This shows, continued Bearwarden, that as long ago as towards the close of the 19th century, the old idea that we saw nothing but the clouds in Jupiter's atmosphere was beginning to change, and also how closely the 2 English writers and Professor Hoe were studying the subject, though their views did not entirely agree. A white spot is merely a storm center, passing round and round the planet, the wind running a little ahead of the surface, which accounts for its rapid rotation compared with the red spot, which is a fixture. A critic may say we have no such winds on earth, to which I reply, that winds on a planet of Jupiter's size, with its rate of rotation, though it is 480 million miles from the sun, and the internal heat is so near the surface, and with land and water arranged as they are, may, and indeed must be very different from those prevailing on earth, the conditions producing and affecting them being so changed. Though the storm center moves 260 miles an hour, the wind need not blow at that rate. Later they saw several smaller spots drifting eastward, but concluded that any seaworthy ship might pass safely through them, for though they were hurricanes of great violence, the waves were small. There would be less danger, said Bearwarden, of shipping seas here than there is on earth. The principal risk to travellers would be that of being blown from the deck. On account of the air's weight in connection with its velocity, this would necessitate some precaution. The next object of interest was the great red spot. It proved, as Cortlandt had predicted, to be a continent, with, at that time, no special color, though they easily recognized it by comparing its outlines with those of the spot in the map. Its length, as they already knew, was 27,000 miles, and its breadth about 8,000 miles, so that it contained more square miles than the entire surface of the earth, land and water included. It is clear, said Cortlandt, that at some season of Jupiter's long year a change takes place that affects the color of the leaves, some drought or prolonged norther, for it is obvious that that is the simplest explanation. In like manner, we may expect that at some times more white spots will move across the ocean than at others. On account of the size of these continents and oceans, said Bearwarden, it is easy to believe that many climatic conditions may prevail here that can scarcely exist on earth. But what a magnificent world to develop, with its great rivers, lakes, and mountains showing at even this distance, and what natural resources must be lying there dormant, awaiting our call! This constantly recurs to my mind. The subjugation and thorough opening up of this red spot continent will probably supply more interesting problems than straightening the axis of the earth. At our next visit, replied Ayrault, when we have established regular interplanetary lines of travel, we may have an opportunity to examine it more closely. Then they again attracted the nearest moon beyond which they had swung, increased the repulsion on Jupiter, and soared away towards Saturn. "We have a striking illustration of Jupiter's enormous mass," said Cortlandt, as the apparent diameter of the mighty planet rapidly decreased, "in the fact that, notwithstanding its numerous moons, it still rotates so rapidly. We know that the earth's days were formerly but half or a quarter as long as now, having lasted but 6 or 8 hours. The explanation of the elongation is simple. The earth rotates in about 24 hours, while the moon encircles it but once in nearly 28 days, so that our satellite is continually drawing the oceans backward against its motion. These tidal breaks, acting through the friction of the water on the bottom, its unequal pressure, and the impact of the waves on the shore, are continually retarding its rotation, so that the day is a fraction of a second longer now than it was in the time of Caesar. This same action is of course taking place in Jupiter and the great planets, in this case there being 5 moons at work. Our moon, we know, rotates on its axis but once while it revolves about the earth, this being no doubt due to its own comparative smallness and the great attraction of the earth, which must have produced tremendous tides before the lunar oceans disappeared from its surface. In crossing the orbits of the satellites, they passed near Ganymede, Jupiter's largest moon. "This," said Cortlandt, "was discovered by Galileo in 1610. It is 3,480 miles in diameter, while our moon is but 2,160, revolves at a distance of 678,300 miles from Jupiter, completes its rotation in 7 days and 4 hours, and has a specific gravity of 1.87. In passing, they observed that Ganymede possessed an atmosphere, and continents, and oceans of large area. "Here," said Bearwarden, "we have a body with a diameter about 500 miles greater than the planet Mercury. Its size, light-specific gravity, atmosphere, and oceans seem to indicate that it is less advanced than that planet. Yet you think Jupiter has had a longer separate existence than the planets nearer the sun?" "Undoubtedly," said Cortlandt. "Jupiter was condensed while in the solar system nebula, and began its individual existence and its evolutionary career long before Mercury was formed. The matter now in Ganymede, however, doubtless remained part of the Jupiter system nebula till after Mercury's creation, and, being part of so great a mass, did not cool very rapidly. I should say that this satellite has about the same relation to Jupiter that Jupiter has to the sun, and is therefore younger in point of time as well of development than the most distant Callisto, and older, at all events in years, than Europa and Io, both of which are nearer. This supposition is corroborated by the fact that Europa, the smallest of these 4, is also the densest, having a specific gravity of 2.14, its smallness having enabled it to overtake Ganymede in development, notwithstanding the latter's start. In the face of the evidence before us, we must believe this, or else that perhaps, as in the case of the asteroid Hilda, something like a collision has rejuvenated it. This might account for its size, and for the Nautical Almanac's statement that there is a small and variable inclination to its orbit, while Io and Europa revolve exactly in the plane of Jupiter's equator. They had about as long a journey before them as they had already made in going from the earth to Jupiter. The great planet soon appeared as a huge crescent, since it was between them and the sun. Its moons became as fifth and sixth magnitude stars, and in the evening of the next day Jupiter's disk became invisible to the unaided eye. Since there were no way stations, in the shape of planets or asteroids, between Jupiter and Saturn, they kept the maximum repulsion on Jupiter as long as possible, and moved at tremendous speed. Saturn was somewhat in advance of Jupiter in its orbit, so that their course from the earth had been along two sides of a triangle, with an obtuse angle between. During the next 4 terrestrial days they sighted several small comets, but spent most of their time writing out their Jovian experiences. During the 6th day, Saturn's rings, although not as much tilted as they would be later in the planet's season, presented a most superb sight, while they spun in the sun's rays. Soon after this, the 8 moons became visible, and, while slightly reducing the Callisto's speed, they crossed the orbits of Lapidus, Hyperion, and Titan, when they knew they were but 750,000 miles from Saturn. "I am anxious to ascertain," said Cortlandt, "whether the composition of yonder rings is similar to that of the comet through which we passed. I am sure they shine with more than reflective light." "We have been in the habit," said Ayrault, "of associating heat with light, but it is obvious there is something far more subtle about cometary light and that of Saturn's rings, both of which seem to have their birth in the intense cold of interplanetary space." Passing close to Mimas, Saturn's nearest moon, they supplemented its attraction, after swinging by their own strong pull, bringing their speed down to dead slow as they entered the outside ring. At distances often of half a mile they found meteoric masses, sometimes lumps the size of a house, often no larger than apples, while small particles like grains of sand moved between them. There were 2 motions. The ring revolved about Saturn, and the particles vibrated among themselves, evidently kept apart by a mutual repulsion, which seemed both to increase and decrease faster than gravitation, for on approaching one another they were more strongly repelled than attracted, but when they separated the repulsion decreased faster than the attraction, so that after a time divergence ceased, and they remained at fixed distances. The Callisto soon became imbued with motion also, but nothing ever struck it. When any large mass came unusually near, both it and their car emitted light, and they rapidly separated. The sunlight was not as strong here as it had been when they entered the comet, and as they penetrated farther, they were better able to observe the omnipresent luminosity. They were somewhat puzzled by the approach of certain light centres, which seemed to contain nothing but this concentrated brightness. Occasionally one of these centres would glow very brightly near them, and simultaneously recede. At such times the Callisto also glowed, and itself recoiled slightly. At first the travellers could not account for this, but finally they concluded that the centres must be meteoric masses consisting entirely of gases, possessing weight though invisible. "We have again to face," said Cortlandt, "that singular law that till recently we did not suppose existed on earth. All kinds of suppositions have been advanced in explanation of these rings. Some writers have their thicknesses looked at from the thin edge as 400 miles, some 100, and some but 40. One astronomer of the 19th century, a man of considerable eminence, was convinced that they consisted of sheets of liquid. Now it should be obvious that no liquid could maintain itself here for a minute, for it would either fall upon the planet as a crushing hail, or, if dependent for its shape on its own tenacity, it would break if formed of the toughest steel, on account of the tremendous weight. Any number of theories have been advanced by any number of men, but in weight we have the rub. No one has ever shown how these innumerable fragments maintain themselves at a height of but a few thousand miles above Saturn, withstanding the giant's gravitational pull. Their rate of revolution, though rapid, does not seem fast enough to sustain them. Neither have I ever seen it explained why the small fragments do not fall upon the large ones, though many astronomers have pictured the composition of these rings as we find they exist. Nor do we know why the molecules of a gas are driven further apart by heat, while their activity is also increased, though if this activity were revolution about one another to develop the centrifugal, it would not need to be as strong then as when they are cold and nearer together. There may be explanations, but I have found none in any of the literature that I have read. It seems to me that all this leads to but one conclusion, viz., apergy is the constant and visible companion of gravitation on these great planets Jupiter and Saturn, perhaps on account of some peculiar influence they possess, and also in comets, in the case of large masses, while on earth it appears naturally only among molecules, those of gases and every other substance. I should go a step farther, said Bearwarden, and say our earth has the peculiarity, since it does not possess the influence necessary to generate naturally a great or even considerable development of apergy, the electricity of thunderstorms, northern lights, and other forces seem to be produced freely, but as regards apergy, our planet's natural productiveness appears to be small. The omnipresent luminosity continued, but the glow was scarcely bright enough to be perceived from the earth. I believe, however, said Bearwarden, referring to this, that whenever a satellite passes near these fragments, preferably when it enters the planet's shadow, since it will remove its own light, it will create such activity among them as to make the luminosity visible to the large telescopes or gelatine plates on earth. Now, said Ayrault, that we have evolved enough theories to keep astronomers busy for some time, if they attempt to discuss them, I suggest that we alight and leave the abstract for the concrete. Whereupon they passed through the inner ring, and rapidly sank to the ground. This is the end of Chapter 14 in Book 2 of A Journey in Other Worlds. Recording by Tom Weiss.